Hello everyone, today I will present you our project, the automatic plant watering system using an Arduino Uno. This system helps to water plants automatically by detecting soil moisture, checking water tank level, and controlling water pump, ensuring plants get right amount of water without wasting resources. This system can be especially useful in agricultural area, home gardening, or even in greenhouse environments where precise water management is crucial. And this is our project motivation. Plants need a regular watering, but sometimes we forget or are too busy, especially during hot weather. Not watering can harm or kill the plants, so we decided to build a simple and low-cost automatic watering systems. We use 10 hardware components, which are relay module, Arduino Uno, breadboard, water pump, soil moisture sensor, wire, LED light, 330 ohm resistor, HCSR0 ultrasonic sensor, and passive buzzer. For the overview part, we are going to talk about the hardware component setup. First, we have the Arduino Uno, which is the brain of the system. It handles all the logic and control for the sensors and output devices. Next, we use soil moisture sensor. This sensor measures how much moisture is present in the soil. If the soil is too dry, the system knows it's time to water the plants. We also use ultrasonic sensor, especially the HCSR0. This sensor measures the water level inside the water tank. If the water level gets too low, we are immediately alert. For visual indicator, we have 3 LED lights. A red LED to indicate when soil is dry. The green LED is to show when the soil is wet, and blue LED to warn us when the water tank level is low. We also include a buzzer, which is active low. That means it will sound when we set it to low, acting as an alert if water running low. Finally, we have a relay module. This component allows us to control the water pump electrically based on the soil moisture readings. For the pin and variable configuration, the first step in the code is defining the pins for each component. This is done by using #define. It is a processor directive. It tells the compiler to replace every instance of the word, such as name moist pin, with the value A0. This makes the code easier to understand and change later. For example, if we want to change the soil sensor pin, we only need to change it here. Next, we declare the threshold values. Int dry threshold equal to 650. Int water level threshold equal to 7. Dry threshold is the moisture level where we consider the soil to be dry. Water level threshold is the distance in centimeter where the water level is considered too low. Setup function runs once when the system is powered on. Here we configure the pins. Pin mode, set the pin to input or output mode. Serial dot begins 9600. Initialize serial communication at 9600 bits per second for debugging.
The loop function. The loop function is where the main logic continuously executes, and we have divided it into 5 parts. Reading soil moisture part. So the analog read function will read the voltage from the sensor and reprint the value to the serial monitor for debugging. So in this slide we are showing the output from the serial monitor. This is where the real-time data from the soil moisture sensor is displayed. The value helps us monitor how wet or dry the soil is at any given moment. And below that, as you can see, we have a section of the code from the water level logic part, which we will explain it in more detail at that slide. To controlling LEDs and pump based on moisture. If the moisture is low, the red LED will light up and the pump will start. But if the moisture is sufficient, the green LED will light up and the pump will stop. So for the moisture level, we know the value from the previous part. Okay, I will explain more about what happens when the moisture value gets high. In our system, a high moisture value actually means the soil is dry. So at the previous slide that I say the moisture is low, it means that the soil is dry. When that happens, the system will automatically activate the water pump to water the plant. So this logic ensures that watering only happens when necessary, and it making the system efficient and plant-friendly. Measuring water level part. So this block is trigger the ultrasonic to send out a sound pulse and wait for the echo. And for the pulse in function, is measure the time taken from the echo to return. Water level logic part. From the code, as you can see that the distance equal to duration multiplied by 0.034 divided by 2. From this formula is convert time to distance. And from the code it says that if the water is low, the blue LED will light up and the buzzer will make a sound. Loop delay part. So from the code, it means that we wait for 5 seconds before starting the loop again.
ฉันถ่ายแล้ว
There are two classes to represent different conditions. The first one is the left glass as the water tank, and another one is the right glass represent dry soil. Initially, the soil moisture sensor reads the moisture level from the left glass and detect a dry condition, triggering the red LED and activating the water pump. Water continues to flow until the sensor reads a moist value that fits the wet moisture condition. At this point, the red LED turns off, the water pump stops, and the green lights up, indicating optimal soil moisture. A few seconds later, the ultrasonic sensor checks the water level in the left glass, and it is below the threshold we set. The buzzer sounds. the blue LED turned on, signaling a low water level. Then we pour water into the left glass, and as the water level reached the threshold, the blue LED turned off and the buzzer stopped. Yay! Completes the cycle.
The benefit of this system. So this project has several real-world advantages. So for the first one is we can save water by watering only when we need it. And for the number 2, we can protect the plant when the owner is away. And the last one, we can reduce human effort in daily plant care. During the development of this project, ChatGPT was an assistant in helping us troubleshoot errors. It made the process smoother and improved our understanding. And this project idea was also inspired by resource and reference project from the Project Hub website by the username LC Lab.